All right, let's kick this thing off. My name's Grant Erickson. This is Austin Frostad, and did I pronounce that right? Is it Frostad or Frostad? Frostad.
I guess if we were in Europe, you could say Frostad.
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 Well, hey, great to have all of you join us today. And we have a few little. Aaron usually does the intros, and I'm obviously not as good as Aaron, but I'm going to give it a shot. So, Austin, can you click through a few of those slides up there?
Yeah.
Give people an idea. So. Anyway, let me talk just a little bit about Austin and some of the stuff he's done. This is Austin with his mad airplane, and you're going to talk about this a little bit during during the presentation. Oh, great. So tell us about it.
Well, I got some past projects here because I don't know if you guys are. I hope all of you are Raspberry Pi fans, and if you're not, I hope I have you guys converted after this. Such a fun little device. So here's a project I did. I got a public school network, and I needed internet for it, but I want to use personal LAN. So I used a Raspberry Pi to sign into that network and then translate all that stuff and share it to my personal Wi-Fi network. So it looks like I just have a personal hotspot here at the office,
which we're hoping to start. And I think our next one is actually going to be in the fall, which we'll talk about in a minute as far as our meetups. But hopefully we'll be having a chance to do those in person. So that's what we're shooting for. And maybe you can come and check out the gate.
Yeah, check out the gate. So yeah, we needed a way for everyone to be able to get into the office with this power gate. And you can buy a remote, of course, but how many remotes and then who has them and all that stuff. So Raspberry Pi. It hosts a Wi-Fi access point near the gate, and if you pull near the gate, you connect to that Wi-Fi access point, and you hit REST endpoint that will operate the gate for you. And we have an app that does that, automatically connects you to it, and it works. It works always for me. For other people, it doesn't seem to work. So I think it probably has 1-star review, but for me, for 5 stars. Oh, and here's the plane.
So tell us a little bit about what the plane does.
So the plane was, I wanted to do some automatic delivery drone, autonomous flying, and so.
They had really hungry nieces and nephews.
Yeah. Well, down the street there's kids, and Well, I got nieces and nephews, and I love to drop parachutes, right? Well, I needed a way to drop them from a higher altitude, all the Army men. So here's what this is what I constructed. It has a Raspberry Pi in here. It's kind of hard to see, but that's where it's sitting. It uses a Raspberry Pi webcam. It's got a 4G modem, and this thing, you just send it off on missions, and it'll fly around. Or
so it's streaming back video.
It's streaming back video.
You can also control some stuff on it, right? Like
Yeah,
you can obviously control where it flies and all that.
And so you can fly it manually with the joystick through the internet. And that's what this picture is.
It also has some flight control software, right? So it can circle and things like that.
Yeah, it runs a very popular flight control system. So it'll just, you can send it off, and it runs a mission and will deliver stuff. And it also is armed here, as you can see here. It's firing off a model rocket. So that was pretty fun. We did that on 4th of July with the kids, and dropped a lot of Army men from the plane. And then this is a fun little project. Actually, you'll see here the Pi that I'm currently using. I had to take it apart, this box, but I wanted to show this project off because it's really, if you need to make a case, you can do it with hot glue and some corrugated cardboard. And as you can see here,
if I spend $30 on Amazon, when you can just use the Amazon box, you just got it.
It's pretty durable, and you just put some toothpicks in there, venting through the corrugation, right? And just hot glue the thing together. So, but this thing would play samples from a Yamaha grand piano. So when you played it, it actually just sounded like a Yamaha grand piano. So pretty cool. All right. Oh, no, this is today. So
right. Yeah. Tell a little bit about what we're going to do
today.
It's really short because I have to go into some more slides too. So come back.
Okay, cool. So real short today. We're just going to show off some cool features that I've learned here in working with Raspberry Pi and .NET. How to debug and deploy an app to the Raspberry Pi, debug it. And then we're going to use Signalr, we'll talk about later, which is a really cool tool that allows us to basically remote control the Raspberry Pi, and then also get feedback right away from the Raspberry Pi. So we can see the state. You can share state. It's pretty fun.
Cool. And I think what I realized is that I have some other things I have to do before that. So just a second. I need to get how do I get the stuff up here? So there's the code. Now I want to get, where's the slides that Aaron sent me?
Oh,
Yeah, I just tried to open them and they must not have opened.
Oh,
Yeah, where's,
you can open up Teams if you want. Right there's that. That's it, right?
is this it? Oh, there it is. Fantastic. Okay. So here's some intro slides that Aaron was supposed to talk about. Oh, no, this is Teams is horrible. Oh, did I say that out loud? I want to open this in, this is, oh no, this is regular versions. There's some nice stuff set the slideshow.
Then you have the
Right.
slideshow here.
And why isn't it going
slides?
from the beginning? Why doesn't it work?
I don't know.
Well, we're just going for it. So anyway, this is Austin. My name's Grant. These were the slides I was supposed to go through ahead of time. Aaron's going to be really mad because I didn't go through these. We got into the wrong slides first. Of course, that wouldn't have happened if she would have been here. So anyway, what we at Intelitech do is a lot of software development and things like that. And what we're hoping is that we can create really a dev community for Spokane. And now, because we're doing all these things online, that other people outside of Spokane would also be involved. And so we have several different meetups that we sponsor. And this one obviously is a .NET users group. The next one will be in the fall. So we're kind of going to take a little summer hiatus unless somebody comes up and says, hey, I really want to do this and has an idea. But Mark Michaelis, Kevin Boss, we're going to talk about nullability. Done a lot of work around this and understanding some of the new features in the latest version of C# and the .NET framework, just so that this is a huge thing when you look at how we can write code that is just more error-free by using some of the new nullability features. The second one, Python users group, headed up by Joseph. They meet the third Tuesday. All kinds of stuff. I guess typing for fun and profit is going to be the next one they're doing. And then finally, the DevOps users group, which Phil kind of heads up, and they'll be meeting Thursday, July 15th. Talking about Kubernetes, of which I have been learning some stuff over the course of the last few days. Incredibly powerful. It can be a little daunting at times, but I would really encourage you to do that. I mean, the idea of being independent as far as which cloud you deploy to by being able to use things like Kubernetes and Helm and things like that, pretty amazing and powerful stuff. So anyway, follow us on social media, and you've already met us because we did the slides in the wrong order. And that's it for that one. We do have a drawing at the end. I'll be drawing probably about 15 minutes before we end. And we have I think is it an IntelliJ thing?
Anyway. Oh yeah, no. It's
like we have some cool free stuff, right? It's like some free stuff.
You get a whole package of all the IntelliJ stuff.
A whole pot full of awesomeness. So let's go back, Austin. We'll kick it over, let you do this thing here.
Yeah.
And we'll pull up the slide here. Is this the next one?
Yeah.
Boom, it's all you.
Okay. Yeah, that was like that was our segue into that ad.
Yeah.
Thanks for, sorry, you can't skip it. YouTube premium. So we got today, this is the architecture of what I'm gonna attempt to kind of show. It's like a demo slash, like build it out, just code along, how it's gonna go today. I got here my Raspberry Pi on the desk, and here's the setup here. We got a servo motor here that has, you can zoom out here. We got a servo motor that has, well, we can show some degrees on it. And we got 2 push buttons. One will make the servo motor go up, one will make the servo motor go down, or in terms of the angle.
So does that work right now?
It's not on.
Oh, it's not. You got to turn.
No, yeah.
Okay.
I don't want to tease them. Not.
That's right. Good. Okay. Sorry, jumping ahead here.
All right. And that's what we're gonna do is when we press this button, we want the goal is we want to not only see the change here, but see the change immediately in our web app. So that is what we're gonna do. We're gonna make it so that a person can either use the buttons, they can either press the buttons or use the web app. And if you press a button, it shows up in the web app. And if you press use the web app, it shows up in the servo motor here on the Pi, and it's instantaneous. So some real-time IoT with, and we'll do that with Signalr and ASP.NET and all the other goodies that have been mentioned. So I guess we, without further ado, should get started here. That one.
That one.
There we go. So first, we gotta, Grant always tells me to keep it simple, all right? Because sometimes I get a little ahead of myself. So first, what we gotta do is we gotta build a servo controller. And I'm gonna kind of gloss over this a little bit, but just show the fundamental bits and pieces of doing what we call GPIO, accessing the GPIO pins on the Raspberry Pi, right? Which is the
GPIO stands for
general programming,
general purpose input output.
Yeah,
Is that-
general
is that what it
purpose
is?
input.
I was guessing.
Yes, that's what it is. General purpose.
By the way,
input
I'm the
output.
guy who doesn't know a lot about this, so I'm going to be asking awesome questions when he kind of goes fast over something and think, hey, we need to let people know what that is.
I thought I was the guy that didn't know much.
You know way more about this, man.
All right, so we're gonna build that, right? We need a way to control the servo motor. This was actually kind of complicated.
So what exactly is a servo motor? Right? Just so people know, what's the difference between a servo motor and another kind of motor?
Okay, servo motor, you send it a signal and it spins based on how much signal to a certain position.
Okay, so you can basically tell it what angle in this case.
Yeah, what angle.
So if you were looking at this picture here, you can tell it to go to 50 or 80 degrees or whatever.
You send it a pulse, and so I can pull up here. I guess we close this presentation. I'll do this.
Wrong one. Just pressing buttons.
So in the GitHub, there's also a GitHub for this project, right? Intelitech samples. So I'll make sure everyone knows about that. It's right here.
I can share that out just a minute. Go ahead. Keep going.
Cool. So there's this GitHub here, and so you can check it out, follow along, see what I'm doing if it gets confusing. So it's Intelitech-samples, raspberry.net.
Okay, got it.
And first, I guess we could talk about real fast about servos. Here's servos. So there's all these references. I put a bunch of references in the GitHub here for all the steps. One, .NET dev resources, like what kind of things you need to know, which I'll go over. And then also working with general purpose input output on the Raspberry Pi. And then some pro tips here that you'll want to check out for doing Raspberry Pi dev. So where are we at? Okay, yeah. Sorry, servo motor. So give a little context for servo motor. Here's a servo motor. A servo motor, you give it a pulse. And this pulse is basically, there's a window, right, between this and this time, and you give it, in that window, you give it a pulse that has a certain duration. And based on that duration, the servo motor will rotate to a certain angle. And servo motors have a specific range in which they can go to because they're locked by a set of gears. And so that'll be part of our program, is we want to make sure we don't overwork the servo and it starts pinching its gears, because they're very, very powerful. They can move like almost 9 kilograms on their little thing at the fine point. They can turn that much, but of course it's the fulcrum, your torque changes, and so they can't actually lift that much. Or no, 2.4 kilograms, I think.
Yeah, 9's a lot.
Yeah. Okay.
It's like a 1-year-old.
Yeah, but they're beefy for these so they're good for like moving levers and stuff. Okay.
Yeah, we use them in our chicken house to open up the door and stuff.
Really?
So it's perfect. Yeah.
That's cool. So that is that part. I got my script here so I can make sure I don't get too cut off.
Yeah, so it does use pulse width modulation. So that's really what that is. You're sending a pulse with a certain amount of on, and based on how much it's on, that determines, just to answer the question here that was in the comments.
Yeah. So it uses PWM, and you can read about that a little bit right here. There's all sorts of devices use different types of PWM frequency and setup, and so we'll set it up just for servo motor.
Right, but in a lot of ways, this gets hidden based on the library. So we're just going to use a library that we can give some kind of C# stuff to, right?
Unfortunately, there wasn't. I had to do it.
Oh, yeah, do it by hand.
Yeah, do it by
Okay,
hand.
well, there's no library this time, but there's some library. I mean, you're using some kind of.
Yeah, there is,
some kind of
yeah,
stuff,
yeah.
yeah.
Well, I'll pull up, I'll show you, there's a library that we do
Let's
get to
jump in.
use. We're jumping in here. We're gonna create a new project, new solution. Let's create a new project. Go fast. Look how fast it's going. All right, so we're gonna start off with, we're gonna make that console application here. We never make a console app that lives on the Pi that we can run. And
This will just be running on the Pi,
Mhm.
and it's listening for servo commands through Signalr, and it's going to give servo commands out
Yes, exactly.
to the servo.
So it has got two parts, Servo Controller and a way to connect to our web server. So we're gonna start with the Servo Controller. So we're just going to create that console app here. And we'll call it Raspberry console. And we'll put it in the solution called PyDev. Cool. And we'll go for it. We want to use 3.1 currently. There's 5 is still a little, I don't know, I just read the box. Still a little not fully supported by the Raspberry Pi or some libraries that we'll need to use. So we made a cool console program here, and then we'll want to add a new project for, let me pull up my references here. We're at a new project that is just actually, we just need a class library. Oh no, yeah, there we go. That's where we're going to put the servo controller. So come in here. I clicked new.
Yeah, right there.
Right here. Add.
It's a better spot. New
Yeah.
project. Perfect.
Class library. And we'll call this Servo IO. Cool. So first we need to build that servo controller. And so what we'll do is first, yeah. So the libraries I discovered are, I'm gonna pull up here on GitHub here. So when you work with the GPIO, and there's this cool tool here called, where's it at? Uno Square. So Uno Square is what we're going to be using here. It is a library for working with all the features of, and it kind of explains actually in here too, like how you do, how we're going to deploy, but how to do all the features for working with GPIO. So there's a lot of stuff in here, but here's what we're going to do. Hardware PWM. And so it's telling us that we're gonna, we need to create a pin. And so we have to figure out what pin to use on the Raspberry Pi. So that's an important thing. If you don't know the pins on the Raspberry Pi, you can't do much. So there's also, we refer to this pinout chart here.
So certain pins are GPIO pins, and certain
Yeah.
pins do other things. They
Yeah.
have power on them or do some other kind of.
Exactly.
Some other kind of thing.
And we're going to use these 2 pins, or we're going to use, I think I'm using this one right here for the servo motor. So it's GPIO 19, and that's how we reference it. And you always make sure you have to reference it, because there's also, depending on what library you're using, it may be pin 24 or it's pin 19. So this is called GPIO 19, and we're going to reference it that way. So it's important to take note of what library you're using and what pin number it is actually.
And that could be pin 35 actually
Yeah.
on the board.
Yeah.
It's just a little
But
bit, so
actually
it's a
pin-
little bit confusing.
Yeah, so here's an overview of the board, and that's what it's looking like, right? So it's actually pin number 35, but it's GPIO 19. So that can trip you up if you're like plugging things into the wrong spot. And plus some of the ports don't do certain things. We're going to be using, as we saw here, there's hardware PWM and there's software PWM. So certain pins don't do software or don't do hardware, but we're using 19, which does happen to do that. So we will go ahead, and what I'm going to do is here is
You're gonna bring in the code, or you're gonna
bring in the code. Bring in the code.
Yeah, there's a lot of it. Let's just bring it in. Good idea.
Yeah.
Just the whole thing. Yeah.
To expedite this process, because it almost seems like I thought like, oh, how much can I show? And so we'll want to get the Uno squared library here. So what I'm doing is creating a servo pin because we're going to work with that pin, and that's the most fundamental unit. The pin can either be set, Raspberry Pi pins can be set to either input or output. So a servo pin is a pin set to output, and it has certain features configured on it, such as a servo clock divisor, servo PWM range, and these are all things very specific to servo motors. And then right here, here's the max pulse and the min pulse for that. We're talking about those pulse windows. And I figured these are out. These were healthy ones for my servo motor that I'm particularly using.
So that's how far you can push it.
Yeah.
How wide that pulse is. We saw
Yeah.
that pulse, kind of that square wave. Is how much of that square wave can be complete. So it's kind of from about this much, maybe to that much, and there's some on either side.
Yep. And so we will create that servo pin, and when we create it, we're going to pass it in our pin number, and we're going to set the pin node to output. We're going to you have to use mark signs. There's a certain type of frequency. We're using mark sign. Set all the things on it, and then right here I have what we need a servo pin to do. It needs to write, and we need to read it, like get the value that currently is at it, right? You know, its state. So I got one method here for writing the pulse, and then I have a little safety check here that says, hey, if it's above or min the pulse, like it won't do it because we don't want to damage the servo motor. It'll overcrank itself. And literally, once it's all set up, we can do pin.pdm, the register of the pin, and we just literally sign it in the value. And that's how this library works from Uno Square Raspberry Pi IO. So we get a GPIO pin, a lot of configuration, and you can read about that in the links I have, or you can just use what I have here for your start if you're working with servos. And so yeah, so we just gotta be able to release and write and read. And read is simple as in just what is the PDM pin register right now? What is the value? So that's how we can do that. And then I wrote some methods here for increasing the pulse, and decreasing the pulse, because I assigned those to the buttons. So
we need to bring in a library to get rid of all this red, right?
yeah, we need to bring in the library. So we need Uno Square Pi and Uno Square abstractions. And we'll see how much we do of this. It all seems so simple. So we can bring those in.
Ooh, yeah, I just saw you use that Windows key V.
Yeah, did I
To pull up your
secrets in-
history.
Do I have secrets in there?
Well, probably.
I was doing some database stuff already.
No, but that's a great little pro tip there.
Oh yeah, yeah.
If you're wondering about that.
Yeah, use Windows V if you turn on your clipboard history.
Yep.
That's nice because then you can go through here and you can get through a bunch of stuff. I'd scroll more, but there's
Secrets.
secrets.
Gotta be careful with the secrets.
Yeah. So
Okay, great. So we should be able to compile now. We're close to it, maybe. One more wiring pi.
Wiring pi. So wiring pi is actually, this is a good thing to know what wiring pi is. Wiring pi is a C library, I believe, written by this geek dude, and it is kind of like the de facto way to do GPIO stuff on the Pi. And it's like you can install it on your Pi and do like command line wiring pi this, and so it's kind of a fundamental thing for working with the GPIO pins. And they've wrapped it for us nicely.
Boom, no more red.
All right, so we got our servo pin. and we'll come in here. Let's just rename that.
Name the class, make it proper.
And then, so we got our servo pin, and then I want to wrap that in another class called Servo Controller, because I want to be able to press buttons and have them increase the angle. I don't want to think in PWM. I just want to think in angle right now. So I'm going to create that.
So really this, if somebody wanted to do a servo like this, they could kind of take this base level class,
Yeah.
not base class, but this bottom level class and use that for their own servo potentially.
Yeah. So, and our servo pin, right, we need, the goals we need for our servo controller are increase the angle, and when we're pressing those buttons and setting the angle, like we could just pass in any angle value and it'll just go to that angle on the servo. So let's go in here. Again, I got big old class. Oh, I created a nice, we're not going to use that. Another project I have an interface, and that makes it a little nicer. We don't really need to do Microsoft anymore, actually, because we're going to use that for this project. So, sorry, let's just do that. And we don't need that method. Okay. And we don't need those two methods. Microsoft also has a GPIO library just for working with GPIO on any machine. And it's actually pretty good. And I was messing around with that too. And but we won't use it for today. So we got our servo controller, and what's the name? That's called Servo IO. Cool. So our servo controller.
Choose the top option, undo that, and then because you opted for not yet. To the top one. Using pi.io.
Yeah.
Oh, you didn't change it to, you didn't change the namespace of the other.
Oh, the other one. Oh, okay.
So go back and change the namespace to servopin.cs.
Oh, what's the view? Servo IO. I have to put this on all of them. Okay. Right.
Now it should just work.
Yeah. Okay, so the servo pin, servo controller gets the servo pin, and I add the hold on, I'll go into that in a moment. So we have a min angle and a max angle, and currently that's what this servo motor can do. It can do 0 to 150 roughly. I think it's actually 160, but and I do some math in here. So when I do right, I can right angle here, and it does some math and it converts the thing into PWM. And make sure that we don't write angle too big or too small. And we can decrease the angle, or right angle, yeah, so we just right angle, and then we can decrease the angle by 5 by default and increase the angle. And what we want to do now is we got those 2 push buttons, remember? So we got the 2 push buttons right here, and we want to now, we need to use pins for those. So we need to turn those on as input pins. And so I'm going to listen for those buttons here. I created this method right here that will take those pins if you pass them in. So you pass them the value of those pins, which I know are, I think, GPIO 23 and GPIO 24. And I set the pin mode as input, and the input mode is pull up. So that sets the default value. That means that the circuit is live and hot. And when I press the pin down, the push button, it's going to complete the circuit. And so then I'm detecting when I have a falling, falling edge.
So when you let the button up.
Yeah. Yeah. So yeah, that should be right. So yeah, the falling edge, it should be a rising edge, but it works with falling edge. I was having a lot of finicky stuff with this library, and so it's very nuanced, but it's going to set the, basically when we press the button down, it completes the circuit, and when we let go of the circuit, it stops this, close it, or close the circuit and open the circuit when pressing the button. And that interrupt right here will get called based on this logic. So we're using that GPIO pin, and we add this interrupt call, and we have an up pin event handler and a down pin event handler. Am I making sense?
Yeah, I think that's good. I mean, I think that just calls things down here.
Yeah, so I got
Great.
my
So it's
two
just a
handlers.
delegate,
Yeah.
C#.
And when that happens, it'll just increase the angle by 3 and decrease the angle by 3 based on those things, and log whether the up button and down buttons are pressed. So we got this handler right here. So we have basically what we want to do is call this method in our. So then we got a servo controller, and we've got ways to increment. And we got servo controller, we got the servo pin, and we got 2 pins watching for inputs. And so when I press those buttons, we get these events will get called.
So we have a question. Can you read the angle from the servo motor?
Can we
And
read the angle?
yeah, and I think the answer is that the servo motor goes to the angle that you tell it and then holds it there.
Yeah, it holds it there.
So it's not like you can just like, I asked Austin this too just the other day. I said, hey, can you just move it? Well, the answer is you can't, because it's always giving it a pulse. And so it's going to hold it at a particular thing. And it'll like almost like strip the gears if you try to move it. So it is holding it in one spot.
Yeah.
Hopefully that answers the question. If you have another question, feel free to post
it. It just does whatever the current PWM. So you can always read the current PWM output, whatever that pulse is, because it's always active. On the way it works with the PWM output on that pin is it's just constantly setting that same pulse, and just constantly. And then the servo motor stays in that static location unless the PWM goes up or down. So.
Oh, there was a question about which Pi we're using. Pi 3?
We're using a Pi 3 right now.
Okay, not a Pi 4. So
not a Pi 4. Yeah. Cool.
3B, right?
I think this is just the 3.
This
Oh, it's 3B. This is
3B.
3B
So
version.
Pi 3B.
Yeah, Pi 3B. And so I did write a method that converts the PWM back into the angle based on that. But the angle, you don't know what the angle actually is. All you know is the PWM, and you hope it goes to that right angle, right? And that's usually consistent. So in our program now, I'm gonna run that program. Come over here, get my cheater. It's called program.
This is basically the entry point.
Yeah, so I use a library called, so I want to be able to pass some arguments in here. I'm going to throw them in here.
So we'll take the whole thing.
Yeah. I guess I'll just take the whole program. Here comes the program.
Just remember to change the namespace.
Change the namespace. All right. Let me go. It's just. Oh, this one is. Wait, we can leave this one.
This one was already right.
This is Raspberry console. Okay. And we want to now Raspberry console, this app. I want to reference the Servo app. So I'm just gonna add I think it would automatically detect it, but
Yeah, it's still left out of project reference.
yeah, add project reference.
Project one up. Yeah.
There we go. Cool. All right, so Servo Controller.
We'll answer the question about which direction it's pointing in just a second. Let's get it going, then we'll show you how it works.
All right, so go back to this bad boy. What did you not finding? Servo IO. Yes.
Is the servo controller not disposable?
It should be, but either way,
Should be
for
disposable.
the
Well,
purposes, we will not.
Why we
Need,
find this?
we won't need to use that. I'm gonna mute that right now, and we can that, and that. All right, cool. We have a lot of more real estate here. What's going on?
Right, cool. Or do you have the TB test or not? You close that if you're not.
No, it's a test. Oh, I still
No.
Yeah, no tests here. It's all integration. So I'm using a library called Dragonfruit for this, and it allows you to. This is how you can do some nice command line arguments here. And so I'm gonna have. I want to be able to. Basically, now our goal is to test whether or not our servo controller works. So this is the product of a bunch of methods that I was doing. I have a set angle where when I run the console app, I just pass in an angle and it will set that angle. I have a sweep function so I can see whether it's working. And it goes from 0 to 180. It should be 150 there, but if it goes over 180, it doesn't matter because it stops at 150 in our controller. So I have a sweep function I can call from the command line. I have a manual set PWN from the command line. And I have, I can test my buttons whether they're working. And we're going to do that here by testing the buttons. So I set my pins that I want to use for inputs, and I go Servo Controller, listen for buttons, and then I just use a console read line. So it just sits there and waits for you to press the buttons. And then if you press Q. So I guess this is kind of the way to do it. If you want to keep your console app running, just put a read line in. And the library you can look up, it's in beta or alpha right now, but it's called Dragonfruit, and that allows you to, it's by Microsoft, to do a console app and just pass in strongly typed variables, right? Without having to do any logic on whatever. It's just, if I type -s when I run this thing, it'll input -s, that will get set to true and it'll run through here. So I can look, S means sweep, G means get the current value, angle means set that angle.
So how do I get that over there?
So now we got this, and here's the cool part here about working in .NET, right? We got to get this thing to the Raspberry Pi, and we're going to do that simply by putting, there's a .NET tool called SSH deploy, or I think that's what it's called. It's in the GitHub. And I will deploy this app here. One second. So I'm going to come to how I'm going to deploy this is by going to my console app. In the property group here, I'm going to add some more properties. I'm going to add my keys. Of course, I just got the default here from my Raspberry Pi. But all I do is I come in here and I go Raspberry console, and when I run this tool, that SSH deploy, it's going to go to my Raspberry Pi. And it is currently, this is a handy thing, your Raspberry Pi by default, when it's on your local network, if it's connected to your local LAN, like via Wi-Fi or cable, it already has a host name called Raspberry Pi. So you don't have to worry about figuring out the IP address of your Raspberry Pi. You can, of course, do that easily. But you can just type it in here because you may change locations. Like I sometimes dev at home, dev here. So you just put in your host name, where you want the app to go, your username, and credentials. So I want to
super secure secret password.
Yep. And yeah, that's all you need to deploy it. And I guarantee, I'd be amazed if this works the first time. No. Let's hope it does. If not, we got backups. So I'm going to come over here, and you run this command from where you're at. So I need to go here, and I need to go open the folder, and I'll get that nice string there. And I'm going to go CD to that. And you just run this command here, .NET SSH deploy push. And
PowerShell window.
it doesn't stay static main entry point.
It's no entry point in your.
I'm confused.
Let's go your program.
Oh. Well, this is why we have to come in here. I was telling people, and of course, here, I wanted to show them where it is. We got to install
I
that.
was wondering if you're gonna put that in there.
We're use dragon fruit. Oh, include pre-releases. There it is. It's not command line dragon fruit. We'll install that. That'll help us out because yes, we do not have the correct farm currently for a program. This is not the correct way for a main program to be done. Now I'll come back over here, run that again.
You're gonna have to save it.
Oh yeah.
Try it now. Let's see what happens.
Let's do a rebuild. Oh, yeah. There the build succeeded, so now we should get a deploy that succeeds. Boom.
Hey, look at this.
And it says, I have never done this. Raspberry console doesn't exist, so it just creates it and then puts it in there. So now I can come
It's a
over.
sweet little tool. That's really nice.
Yeah, and so now I can come over to my connections, open my Raspberry Pi, log in with my
Super secret password. No one
super
knows.
secret password. Oh, I don't even know it. I think I put it over there. Okay, and I'm gonna go with CD because I'm at the home
It's that
directory.
same folder you were in before.
Yeah,
So we
Raspberry
should-
console. And to run this, there's a fun command I can do. Well, let's look at the name. Let's look what it put there. Let's look what it put there for us. Put us all these goodies. And we want to run it. We want to run the name of the app, the DLL. So you want to run Raspberry console DLL, and we'll run that with the .NET. So first you have to, of course, have .NET installed, and that's in the GitHub too, how to install your .NET on the Raspberry Pi. It's just a curl command, and then you add some path commands, and you're set to be able to use it within wherever you're at. So I want to run my thing, and it's called Raspberry console. DLL. And the mode I want to run it in, let's run it in Servo. Let's see if this works. Hopefully it does. We're gonna flip over.
Sweep, right?
Yeah, we're gonna sweep.
Okay.
I'm gonna click enter here and see what happens.
Oh, there's the magic.
The magic, it works. Cool.
Right, and it ran back to the middle. Okay.
Yeah. So there we go. It worked. That's fun. So we'll come back here. You can see I put some output here going on.
Okay, so now let's answer the question. So there's a question here that says, how do you know if it's pointing up or to the left if you add 3 degrees? How do you know where it's pointing, especially when you restart the program? So now once it's outputting on a pin, it continues to output, right?
Yeah.
So it's going to put out what. And now if I just start the Raspberry Pi up, then the pin is not even active.
Yes, the pin, all by default on the Raspberry Pi, all pins are set to input. So you don't have to worry about like putting something in and it doing the wrong thing.
So is it possible to know where it is without sending it anything first?
Well, you can, when you create the pin, you can ask the register what its current value is.
But that wouldn't necessarily reflect what the current state of the device is.
No.
It's just whatever the current state of the pin is just going to set it
Yeah,
to start.
yeah, I'm not sure. I think that's a good question. I'm not sure if we're.
Yeah, I don't know if we have a good answer for you on that. So sorry
the
about that.
The full way, other than I know when we do know that increasing the pulse. I think actually, let's look here. The pulse is at 52 and the angle's at 119. So as you can see, as the pulse gets bigger, the angle gets bigger. And as the pulse gets
Oh,
smaller.
it's the other way.
Is it the opposite way? Oh yeah, it's the opposite way. See, it's opposite. And that's based on, so I guess the angle doesn't matter. It's like which way, it's all in your orientations, counterclockwise or clockwise, right? In the servo motor, it looks like as you increase the PWM on the servo motor, it looks like
it moves to the left.
It moves counterclockwise and vice versa. So that's all right. Now, what if it didn't work? What if it
Okay,
didn't
time
work?
check, we're about 45, we're about halfway through, but
Halfway
maybe
through?
not quite halfway through.
That's perfect.
Okay,
That's
great.
pretty good.
We're doing okay?
Very good. Thanks for hanging in here, everyone. Here's actually, you can leave after this next bit because this is the most important part. How do you debug it? But actually, you want to stick around because it's kind of, we haven't done the Signalr. So, how do you debug this thing? And so we're going to run the same thing, except for I got in here if debug, and I'm going to pause it. So if I set the debug right here to true, when we run this thing, it'll get stuck right here and wait for me to attach a debugger. So I'm going to show you guys how to attach the debugger so we can figure out what's going on. So I'll set a breakpoint right here at the creation of the servo, and we're going to come in here and go dash dash debug because that's what we want to do. And then maybe we'll have it sweep again. So I'll run that. So now this allows me to pause my app so I have time, because sometimes things are going on in the setup right here, and go to debug. I'm going to click attach to process. And I got to find my Raspberry Pi. So I'm going to go SSH, and I'm going to type Raspberry Pi, which is really nice. I'm going to type in, and currently, this is another thing you'll have to read about the tutorial. I think it's important. I'm going to log in as root because this is actually a root process. If you notice, I have to run the sudo. I have to run the app as sudo because it's using the GPIO, and therefore, I guess that's a root thing. So I want to run this app because it's running as root. So I need to put my, I got my super secure password, root, and I'm going to connect to it. And it should show me all the processes running on the Raspberry Pi, which is really awesome. And I got .NET, right? That's my .NET process. There it is. It's waiting for me to attach. And you click Managed for Unix.
Great.
And you click OK. And give it a moment to do some clicker things. And I think we're in.
And now we have to go back to the SSH.
And look at this. Look right here. We're all in. We got our loading. We got our symbols going.
Great, so now I can go back and press Y when we're ready to go.
Yeah, we can press Y. We're ready. Yay. Boom.
There it is, breakpoint.
We hit our
So we have a
breakpoint.
breakpoint here on the computer, but it's working, it's running in the code that's on the file.
Yeah.
Awesome.
And that's very helpful because
So can you step from right here? Can I press F10
yeah,
and just like watch that?
yeah, you can step through it here. So we should currently be able to click on S here and see it set to true because we're gonna do
okay, so we can check out variables and all that.
Cool. And scroll down here to sweep, right? And we can come into the sweep method and we can just click
step and go.
Continue. We'll come right in here. We're in the sweep method and we can do servo angle right angle and yeah.
If you start stepping, so now I'm going to show you the servo. Okay, go ahead and start stepping. Sorry, you can't see the code at the same time. So there we go. We set the angle. I'm going to flip back and forth here, kind of give you an idea of what's happening. So there we go. Boom, there it is. You can kind of see it.
It's incrementing. It's increasing it by like one angle at a time, right? So it's going to go really slow.
You barely see it moving.
But
as he goes through there,
they can watch it run. You can see it's outputting stuff.
Back.
Cool, and then we hit our other breakpoint. So this is really handy to figure out, hey, what's going on? Of course, like that's what debugging is, right? But very handy because you have to deploy this stuff. You can write your software and like maybe mock a pin or whatever and run your software and see how it's going. But there's no way to do GPIO, without integration.
Real on the outside.
Yeah, on the outside. So very helpful. That was again coming in here. One, just put away this stopping program right at the startup, and then attach your debugger. And once you do it, it's kind of nice because it'll just remember.
Cool. So now we want to get this thing attached to the cloud.
Yeah.
So are we good? Are we all set? Or there's a so we have to build copies.
Yeah, we haven't done we haven't tested our buttons here.
Oh yeah, let's do that.
We test the buttons. So I'm gonna quit the app here. Let's run it again. So because people haven't seen the buttons. And we want to test buttons, and the button command is listen for buttons with Uno square. So I want to do --UB. And I want to get Raspberry console hub. No, I don't want hub. I don't want to connect to the hub.
You don't want to debug either, do you? Or I guess
It's okay. Yeah.
you don't need to attach debugger.
Yeah. So I could have removed the debug. So now I have, remember in that task, I just put here, once again, wait for the read line. And hopefully I've attached my thing. So now when I press these buttons, I can increase the angle and decrease the angle.
By 3 degrees at a time, right?
Actually 6, because the Uno square
and down.
registers the click on the up and on the down. So
Yeah,
it
yeah,
does
yeah.
it twice. The Microsoft one's smart though, and does only 1 click per each. You can specify how it reads the input.
Cool.
Yeah. So yeah, using that pin. So you can read about also how to do the push pin input. And if you want to do more advanced stuff, what you do is then hook up the Raspberry Pi to something like an Arduino, which has better libraries for and has more things it can do better. It can do better input. So like the Raspberry Pi is good at just you can use the GPIOs for like getting stuff in. And interfacing with other devices.
So just real quick, I mean, I guess when I think about the Raspberry Pi and the Arduino is going to be really simple. You're always going to be running in C. It's a really almost like a real-time OS. Not really, maybe even an OS, but it just really runs just really simple commands, really simple programs. And you don't have to be really simple, but it's written more in a more C style kind of thing. Where here you actually have a Raspberry Pi that is running Linux. And in this case, we can run .NET Core, and there's like a full OS, and there's all the accoutrements that you get by having a full OS, as opposed to something that was much more bare bones.
Exactly.
So yeah, you kind of have to pick the right tool for the job, and sometimes now because the costs are, I mean, the Arduino is cheaper, but in a way, you're probably looking at what do I know, how do I want to maintain it, what am I comfortable with doing debugging on, and things like that.
Well said. So we will close the program. And the next step now is
Wow, make pages and pages of notes.
We've done that. We're gonna write that cloud app so that we can.
So you want to flip back to that picture real quick, and we'll take a look at that.
Yeah, exactly. Great call. Here we are. So here's what we've done. Console app. We've done the Servo Controller.
So not the Signalr part yet.
Not yet.
There's some pieces of that in there. We'll put them back.
And yeah, so and we got it. Well, I guess we'll explain what Signalr is right here, because basically I think we hopefully understand what the web server is. We're going to use the ASP.NET web server. And I'm going to use a template to create that. And we have this hub, a Signalr hub. And what Signalr is a toolkit that allows you to use a lot of technologies, communication technologies all at once. And what it really is as you can see here, I have a send and receive. And these are methods. They can be whatever you call. But basically what I can do is I can do a send and a receive. I can send something to the hub. So I have a connection to the hub, and I can send it. I can go send to Pi. I can literally call on here on the console. So like when I press the button, for example, and I go, it increases the angle. Then I can tie into send to Pi, or I'm on that web app. Oh, the wrong way. I want to go to the web app. I can go send to, press button. Now I call send to web app, and it'll forward. And I just call that method. I call on here on the Signalr Hub. I'll call forward to hub and pass it the current value of the servo motor, and it will just forward it right to the hub.
So really, I think the cool thing about Signalr is it provides a layer of abstraction over something that's fairly complicated. For those of you who aren't just kind of aware of what's going on, when you think about how do I want to be able to have some kind of a state on a server, and the classic example is a chat, right? So you have some kind of a chat going on, and I want to be able to put in somebody chat something, and then I want to send it out to 50 people or however many people are on the chat. I mean, that can be a tricky problem, and And the primary reason is because of how the web is set up, all communication has to originate with the client. And so in this case, we kind of have two different things going on, whether you're in the web app itself. So here we're in a web app in JavaScript, running on in this case, like just an insecure client and a browser. And I want to be able to send things back, and I want to be able to allow the server to push things to me, preferably without polling, or I want to have a system where I don't care what the mechanism is. I just want to get an event whenever there's something new, right? And when you're looking at the Raspberry Pi there on the left, it's even more interesting because now I am probably not connected directly to the internet. I'm likely behind a firewall. And so the cool thing about Signalr is that all connections are made from the client to the server, which allows then a connection to kind of be held open or for polling. And so there's several different technologies that it uses, and it kind of fails down through whichever ones are available and uses the best one possible to be able to provide you with this really nice kind of a real-time type connection. So they use a publish and subscribe kind of paradigm with this concept of a hub and essentially a subscriber. That's kind of the guts behind Signalr. There's tons of stuff. We can do a whole thing just on Signalr.
Yeah. But it's
But
what it's
suffice
going
it
to
to
do.
say
It's
that-
going to give us a
Good enough.
WebSocket. It's going to give us a WebSocket connection between the Pi and the mobile app. So
Right.
whoever's running the app.
In this case, because they support WebSockets, it's going to use a WebSocket. It wouldn't have to be WebSocket.
Yeah, it
It
falls
could be
back.
something else. It could be some other.
But you
protocol.
don't know because it's all abstractified, as Grant explained. So that's good.
Yeah, it's actually a pretty good abstraction. I mean, there's a lot of abstractions we talk about being leaky because you have to know a lot about how it works under the covers to kind of really appreciate it and use it. This one really does work well and hides a lot of technical complexity. It's been around for a while. It's been around since the regular non.NET Core days. And this is something this is a good tried and true piece of kit that works both for web kind of apps and for non-web apps in this case, IoT stuff.
Yeah. So let's build that. Let's build that first fundamental thing being the web server. We're going to get the web server and let's make the Signalr Hub because that kind of dictates what we can do. We're going to define methods there that can be called by both the Pi client and the web app client. And they have to go through the hub. So we first make those central methods that can be called on the hub. And so I'm going to add another project here. Add the project. And I got Vue.js with .NET 5 project, which is kind of nice.
So now this one doesn't have to be .NET 3.1
No,
because
it's I'm going to run it on my computer currently, so I'm just going to run it in a different environment. So
right, because this might
Yeah,
run on the cloud
yeah,
or in somewhere else. So it doesn't have to be because we're not interfacing with the Pi directly. We're just going to interface with. We're just going to use the hub to use Signalr to talk to the Pi.
And another thing is this is cool because I can put it in the cloud, right? And I can access my Pi through the cloud. But if you want to do it locally, there's also in the GitHub a way to like you can have the Pi itself deliver this content to you, and so you can just be at home and use a controller, and you don't have to worry about paying for this whole subscription to deploy this thing. But we're gonna put this in here, so we'll call this pi.web because that's what it was in the other project, and we don't have to worry about namespaces.
Good choice.
All right. So it's gonna create me a project. And what we're gonna do, if I'm correct, so we need to make that hub and we're gonna have to bring in Signalr. Cool. And to do that, so we'll get Signalr clients. That's what we want. So first we'll just bring in the package we need, which is Signalr.
You want to turn off pre-release.
Yeah, we don't
We
want
don't
that.
need that anymore.
And we want the client. There we are. Oh no, we want hub. Which one? What
I think
Signalr?
you want to Signalr server for this
Yeah,
one.
we want Signalr.
So in this case,
want
the
the full
hub is going to
thing.
be the server and the client is going to be the far end. So either the web client or in this case, a .NET client that would run on the Pi.
Yeah. I'm gonna cheat here and get the right packages. Click on what's installed here.
Must be the wrong project. Is that your cloud web app?
Yeah. Oh, I think Signalr just included.
No.
I'm so confused. We'll go from here.
Look at your CS project file. Let's see what
It's not in there.
you know, Signalr on your CS project file.
How is it doing this? Magic. Okay, well, we'll go and we'll see why we don't need it.
I will find it in a minute.
I think it's because it's built into ASP.NET now. So let's close all this stuff. We don't need that.
Yeah, I wonder. Yeah, I don't know.
All right.
Surprised you get that by default.
So everything Fusion folks here. Let's go, and what we're gonna do is we're literally just gonna add to this thing, this project, hubs. So let's add a new folder. Called
So just like you'd have
hubs.
controllers or something like that, you have hubs, which is
Mhm.
the convention for building hubs.
And I'm gonna come in here and can I do that? I bet I can. Client apps.
Hubs right there.
I have a great naming here. I have this amazing thing called Cloud Hub that I just added in here. So here's the Cloud Hub. And yeah, look at that. It can yeah, it just grabs it right from Signalr. So it's baked into
Oh yeah, look at that.
ASP.NET right here. Just pull it in
Oh,
using Microsoft ASP.NET.
it must have the one package that includes everything.
Yeah. So what a hub is you got some methods here. It probably would have been better if I didn't have it all coming at you at once. But we need first, right, a way for the Raspberry Pi to send something to the web client, the web app. So I have this method right here called setDegree_pi. I'm still working on naming conventions for this stuff because I haven't worked much with Signalr, but like how to figure this out. But saying this set degree is being called by the Pi. The Pi can call this thing. It says means that the degree has been set, it's been changed. And so the Pi console app can call this method. So each method is literally, you can just do an async task. You can, on the clients can actually wait for a return, but all these methods are just fire and forget. So you can actually call a method on the hub and wait for something to come back to you if you're a client. But in this case, we're not doing that. But just the generic method is a public async task, and that is a method. So the hub, as you can see, all it is a series of tasks that you can write. So this one right here is for the Pi, and it's gonna, once it gets called, all it does is you call this method and we're gonna pass it the degree or the current angle, and then it's just gonna forward it right here. It goes clients, that group, web app client group. So I'll show you that. It's cool. Signalr has groups as well. And so anyone who's in the web app group, you get this message, degree status. So you get this event fired to you with the degree. And that's that. And we go the other way, set degree web app. So if on the web app, if I change the degree, it goes set degree and it forwards it to the Pis. So if you had multiple Pis, anyone in the Pi group, we just have one. But I just wanted to highlight that feature that you can put stuff in groups, just like you have chat rooms and stuff. And you can use authorization as well with Signalr. So if you don't want some traffic on certain hubs, you can route traffic with authorization and prevent things from being done with authorization. But we're not doing that here. We're just doing some simple, we want to be able for the clients to be able to join their respective groups. So the web app client can join the web app group, and the Pi client can join the Pi group. And so we keep those things separate. So we're not firing events to all clients, because you fire them all and then they'll all get it. And then they'll be like, well, I don't have that method. So then they just kind of throw an error. It doesn't crash, but they'll just be like, I don't have that method. So in this case, we make sure that there's methods on all the things. And there's also Signalr hubs also have lifetime events. And so you can have on connected and on disconnected. And so I got an on connected method here that will send to the client that currently just accessed. And it's, yeah, so they send to the client that they're connected. So if they connected, boom. So every hub it's just like controllers. They're just made just for the request, just for when the method's called, for the lifetime of that interaction. So just like an ASP.NET controller. So this is, and you get that context every time. which contains all the information about who's calling the method and whatnot. So this client will have the client ID and whoever's connected, and you get that. So you get lifetime events, authorization groups, and you just get a series of methods. So that's the Signalr Hub.
It really is pretty nice because you can basically take a class, create a class, put methods on it, and then have those projected out to a remote client that they can then call essentially asynchronously, but almost like an RPC, like a remote procedural call.
Yeah. So to get going with using it, you got to come into your startup file, and you'll need some things. You'll need what do we need in here?
Add the hub.
Oh,
that kind of fun stuff.
Yeah, we'll do that. Yeah, so we got to add the hub. We're just gonna add that hub, and we do that with. I'm gonna change that right here. So app use endpoints. I'm just gonna add into there.
That hub line, yeah, that's what.
Literally just map it out like a controller. And I
Namespace issues, but
namespace. No, I just gotta bring in Signalr. Okay, so here we are, and that is that's what it does. So the way you connect to the hub is you go to the website and /Cloud Hub, or wherever the name of the hub is, and you put authorization and that stuff. But here there's none. You just automatically get connected to the hub. So we did that, and here's the thing. When I'm going to run this application, right? I think we can cover this here now. No, we'll continue on. We'll continue on, and then I'll come back to that. So I'm just going to quickly show you.
You have to put in the Signalr part up above.
Where's that?
Right on line 39.
Use Signalr, right?
Up. That part right there. Just in the middle of your screen. It's line 39.
Oh, I just read 39. Oh, it's hiding from me. It was in a region. Thanks. Yeah. So after at the end of your in your configure services, you also have to add use Signalr, and you can specify options for how the Signalr Hub's going to.
So essentially adding this to your pipeline for ASP.NET Core.
Yeah. And so you would do this. Yeah, you could specify and here's some authorization and stuff. But here I'm just telling it to, when you connect to it, any client gets a message every 14 seconds to keep them alive, or not keep them alive. Just say like, hey, you're still connected. So that's going to tell clients that they're connected every 14 seconds. Odd number, but let's make that client now. So we're going to come into the app. We did this. This is in view. So it's I'll just show you how to add it to the project briefly.
Yeah, this is a way of view thing. So we're just going to add it in. And
yeah, just add it in.
Wave our hands. You can go check it out. If you want to do a view thing, just let us know. And
yeah,
basically kind of love you around here.
Come into. So I'd obviously have to install the package and everything, and all those goodies. So I think what I'm going to do at this point is
just move to your other project.
I'm going to bring it over the other.
Okay, so now we've stuck the cake in the oven and put it in for like an hour to 350, or maybe that'd be a burnt cake at that point.
Yeah.
But here it is, out of the oven, bam, piping hot.
It's very similar. Here we are. And then what we're going to do is add this file, Cloud Hub connection.
So this is what is on GitHub, right?
Yes.
So if you went out to the stuff on GitHub, this is what you're going to see.
Yeah. I'm going to open up Visual Studio Code because it's much easier to work with.
It's way better for doing view
apps. To say when we're doing a review of stuff.
Okay.
So here's Visual Studio Code. We're going to come over here. I added, so in my app, that Cloud Hub connection, right? And here's how a Cloud Hub connection works. I'm adding it as a Vue plugin. There's in the GitHub, once again, there's a link to this guy who does this site called .NET Curry. Pretty fun site, and he kind of goes over how to do how he thinks best to use Signalr, and this is what he did. He just puts it in as a plugin. So it's kind of fun. We're going to create a Vue plugin here and make this connection available for all the Vue components. And so my URL changes. all the time, but my hub, this is the name of my computer, right? It gets a host name too. So I can put my host name of my computer on the local network. So it's nice. I don't have to worry about the hub.
And if you had it in the cloud, that would be the cloud,
Let me the cloud.
the cloud endpoint.
And then the port number. And so that's my URL. That's all you need really to build your hub connection. So you get the hub connection builder from Microsoft Signalr. This is the node or the npm package you get.
So the other side of this, so it's the npm client, it's the JavaScript client in this case.
Yeah, so that's all you need is you'll need to get the Microsoft Signalr and build that connection with the URL. And we, in this file right here, we're going to specify what methods we want to call on the hub and what methods we want to respond to coming from the hub. And we do that just with the nice event pattern with connection on and connect. So all you do is you do connection on degree status. So this is coming from the Pi. So it says, oh no, wait. Yeah, forward signal. So I don't know if it's do the question up. Okay, cool. Yeah, so connection on, when it gets called, this method will get called because we joined the web app client group. And so degree status will get called on our thing and it'll pass degree to, and I'm specifying just the connection methods are all within this file. And what we're going to do though is we're using an event emitter called Mitt. So there's another package called Mitt and it has like a baseball glove. So it's like Mitt and it catches events for you, right? So I'm just using this dude right here. And all he does is I'm going to make him a global variable. So I take Mitt, make him a global variable in the app so that all my components can subscribe to Emitter.
So this is kind of like another little, kind of like a pseudo hub inside of your web app.
Yeah.
That can allow my different components inside of Vue to get the information that's coming in from Signalr. So essentially jumping the boundary into JavaScript.
Exactly. And that is nice because, yeah, you just specify your stuff in one place. And you don't have to worry about events all over the place with the connection. And you don't have to use like these terms here with the capital and whatever names. So we're just going to forward that right here. Emitter, emit, degree status, degree. And we can subscribe to that later on in our component.
You have some kind of component that's going to listen to that and display it on the screen.
And then we got our emitter on, and then we want to, so then our component can call this. So now we want to have our component be able to emit an event, and then our emitter right here catch it and invoke it on the connection. So if the web app sets the degree, then we're going to emit set degree web app. And that's going to go and call it
in the connection there in the connection invoke.
Yeah, okay. Yeah, it's going to invoke it on the connection, which is going to invoke it right here. Set degree web app, which will then forward it to the Pis, to the Raspberry Pi, the one here. So that is what's going on there. And we also have a feature to get the degree if we want. So our component if our component just boots up and he's like, hey, what's the current status of the servo motor? You can invoke get degree status, and on the web hub, get degree status, it'll forward it to the Pi, and the Pi will then set degree Pi again, but with the same exact value. And so then that gets forwarded right back to the web app client group. So they all get the current status. And so we add those events, hook them all up, get those listeners going, subscribe, and then start the connection. And it's kind of fun. We start a connection here, and it doesn't have to be this way. It depends on how you do your app, but here it's going to infinitely try to connect. So if it gets disconnected, it'll be kind of try to connect because it'll try, start. If that fails, set timeout, start again. It'll call the start method again after 5 seconds. So, and if it's successful, we're going to log Signalr connected and invoke the join web app client group. So then we get put in that group. And then I'll also set connected status to connected true. So
Great, so we're ready to fire this thing up?
yeah, we're ready to fire this
Now,
up.
do we have to load this version of the application onto the Pi?
No, I think it's already on.
Because the other one, I think we commented out the,
Oh, no, I actually
the
have,
hub.
I have the other one.
Yeah, the other one already,
Yeah, I just put
something's
it
already
over,
loaded.
so, yeah. So, well, we didn't show the Pi Hub yet.
Which
is,
is the
I think,
client, the
perfect,
Pi
right?
client,
So
right?
how are we doing on time?
What do we got, about 15 more minutes?
All right, perfect. Cool, because we've seen this. This is all good. Here's my Servo Controller view. Briefly to show that. It's just got a cool, well, I'll show it up. It makes sense. I took some clock CSS. So instead of having, I could just easily, use an hour handle on the clock and just cheated there. And we got, we subscribed to that. So it's on created. I'm going to subscribe to the degree status. So I get those things, and I'm going to emit get degree. So I get the current status. And then I got some, I got data right here that is being watched by all this stuff. So view, lots of view, but perfect for doing this live interaction, as you'll see. And that's pretty much all you need right here is some simple views. You got view watchers and right here, and it's very, very conducive for doing input and getting output back from the Pi. Cool, so we got that. Hopefully that wasn't too much, but you look through the code, and honestly, making a Raspberry Pi View app, great way to learn View. It's pretty fun. We're gonna come into our Pi now, and we want to add into that program. We could do it in here, but I'll pull it up right here. Here's in my Pi console app. I have a Cloud Hub connection, and I'm gonna build it the very similar way. Once again, I'm gonna build that hub connection. I'm gonna have a right here, build my hub.
So it looks a lot like the one that we did in JavaScript.
Yeah.
Or TypeScript.
It looks a lot like the one in JavaScript. Yeah, I just did JavaScript this time. TypeScript's definitely so much easier.
Okay, so add a closed handler.
Yep. What happens when you close? You can retry. It's gonna retry to connect. And I'm gonna add my methods. So I come down here and add them again using that event pattern, set degree, and on connected. So on connected, it's gonna run on connected, which is gonna join the Pi group, and then set the degree. Update the hub with the current angle, and then yeah, and then on set degree, meaning that coming from the web app, when it gets set degree, when coming from the web app, I'm going to set the degree, and I'm just going to go Servo Controller, right the angle, and so now we got that hub connections. All right.
Great, is that it? Are we ready to turn it on?
I think so. I think so.
So just so we pull the curtain back just a little bit. So in advance, Austin took and loaded this version that has the hub connection into the app running over on the Pi. Is that currently running?
Yeah.
Because we have to make sure that runs, right?
Yeah.
So log on to the Pi and get this other app started.
So I'm gonna go over here. All right, once again, I got us.
So we installed it in 2 different folders. So there's another folder.
And then I can just run the app. Oh wait, no, I don't. I want to go CD console app, and then I should have browse by. It's kind of fun here. Pi got console hub and debug. All right, so I'm gonna run that app, and that's gonna run right here. The program. Here's the full program. Remember, in the program, if I use specify hub, it's gonna use this default connection, which is my current IP, and so it'll connect to the hub.
And that could have just well been like an Azure IP or an AWS IP, but just for simplicity, we decided, hey, there's too much other stuff going on.
Yeah. Initialize the hub, and it's gonna go to the hub and just initialize it. And I believe the only thing that was funky is I added in the initialize method. I want the hub to come on. the hub is going to subscribe to a property change here on the servo controller. So every time I made a property on the servo controller. Oh, it's not going to take me there. On the servo controller, there is a property called current angle. So whenever the current angle changes, because when I do right angle right here, the current angle gets changed.
It's gonna feed it back and send it back up to your
Yeah.
hub, which then pushes down to your web
Yeah,
client.
so the hub doesn't have to interact or come in here. It just subscribes to this thing. So whenever that changes, whenever the hub changes here, I think it's, yeah. It just subscribes to that, and that runs this method right here, which is on, if the degree changed, then invoke set degree pi. And that,
So it pushes it back up to the hub.
Yeah, push back up to the hub.
Relays that back down to the client to
Yeah.
display the current.
yeah,
Okay.
plays it back to the.
Cool.
So I guess that's the only little funky thing there.
So Pi client's running, right?
Pi
Start
client is gonna run.
Okay, and you wouldn't have to start in debug mode, but are we gonna detach? are we
Oh,
gonna
I don't think I
debugger?
pushed the current one, like it always runs in debug.
Okay.
So it's running now. I'm gonna fire up, here's the other tricky thing, because we're coming to the end. In the startup here of the web app, you can do this on both the web app, if you're running it from the Raspberry Pi or running it from the cloud. You probably don't actually do this. When you're developing, when you're doing dev, you're going to be using sometimes multiple IPs, or also if you're developing on your computer and you run this web app, it's going to run on your local host, but we need to connect to it from the Raspberry Pi, and the Raspberry Pi can't get to it, right?
By default.
By default.
It's closed, the server
Yeah.
that runs as a part of just debugging Visual Studio,
Exactly.
Studio runs private.
So go ahead and get yourself this thing called Conveyor by Qt. And Conveyor by Qt is going to take my ISS instance and allow me to access it on the LAN. So you'll see when I run this program.
So now this is kicking off the view portion of the app, the regular part of the ASP.NET Core app is firing up.
And I might have to do some configuration with the view CliServe. Sometimes it doesn't like.
And we could also have run this just on the command line
okay.
with a .NET as well. That would have worked too, using Kestrel as opposed to.
Boom. All right. So it's not working. We'll figure that out in a moment. But here, what we got going on is, this is very important. Here's my local host instance. And now now I can view it on the LAN at this instance. So if I click on that, I'll get the app.
So now are those the ones that everybody's connecting to? That's the port number and everything?
Yeah. And so that's nice. And then the other funky thing in here is you can turn off cores. And this will allow you to just not have to worry about the IP, and you can type in the host name of the computer. And so that's what I'll do on the thing. So now we got to figure out why this is not working real fast. Like, all right, it says it's connected here to the Signalr Hub server. Oh, that's why. Well, let's come in here. I forgot, the Raspberry Pi times out by default in C#. You can't have infinite retries, even though it only retries a few times to reconnect. And I didn't have the web server running at the time. So you'll see as I'll boot up the web server once again here. And then magically it should work. We'll see here, it should update the view app. Boom, did it.
Nice.
So there's the angle 75, here we're at 75. And as we change the value here.
Oh, here we gotta get this. So I'm gonna flip back and forth between the two screens.
Yeah.
Okay. Okay, go ahead.
I'm gonna we can, yeah, so,
there's those two things.
well, here, we'll just show the output here. So like as literally here, so here's web app and here is Raspberry Pi. And as I,
Okay, I'm flipping back and forth. You can see it moving.
so that's pretty awesome. And now the other part is we want to be able to, I'll fire it up on my phone here so we can look at it at the same time. And it's kind of fun because I can type in the name of my computer. So we'll come over here. I can type in my name of my
Here, let's
computer
see.
here.
Try to get it a little more, bit more centered, and because it's just a little too bright. So with it.
Yeah. Ah,
Turn that intensity down. Can you just dim your screen?
there we go.
There we go.
Calm
Awesome.
down.
Okay.
Oh, look at that. There we
Okay.
go. That'll work. So now we want the other way, right? We want to be able to press the button.
And what's
get the
cool
input.
is what you're not seeing is that over here on the computer, it's also changing as he presses that button. So it's, you basically have press the button, the angle changes on the actual physical servo, the angle changes on the phone, and the angle changes over here on the computer. So that's the beauty of Signalr, is that you really just connected another client, in this case from the phone, same exact website, same exact view app that's running on the PC.
So it's pretty fun. So like right now, pretty much I have just a remote controller, just like a good old fashioned, people used to have their airplanes and use, radio frequencies. Now we're using Wi-Fi.
Yeah, and I think what's cool about this is that you see it took a lot of code. I mean, just quite honestly, there's a lot of code going on behind the scenes here. And I'm excited that as we see now .NET Core go to .NET 5, and now really a lot of this IoT stuff become pretty powerful. When you look at the Pi 4 and things coming out, you have a lot of power there. And I think we're going to see a lot of libraries coming out with these things getting even easier, right? A lot more integration between various components and not having to do quite as much low level stuff. Even Microsoft coming out with that thing that you were kind of experimenting with before this. To see how that's actually going to play out, it's going to be super interesting, and I think it's going to become much simpler to do these kinds of things in the future. And it's not horrible now. It takes a little bit of work, and I think once you get it set up and you get some of the abstraction set up, it can be actually pretty easy. But there is still a little bit of pain. But man, I can't imagine doing this even 5 years ago.
No. And the hardest part was doing the servo motor, but if you can do that low level programming, and I like that stuff. But yeah, the hardest part is doing that servo stuff. But with Signalr, it's so cool. Just be able to easily hook these things up, and then a view app gives you an excellent way to do input and output. So really thank you guys for all hanging around and watching this. It was a lot of fun.
Great. Any questions? You want to either throw them in the chat or whatever that looks like. Looks like you have quite a few folks, which is awesome. Phil is clapping. Thank you, Phil. Oh, Esther. Thanks, Esther. Oh, Phil. Oh, now we have a thumbs up from Phil. All kinds of feedback.
Great.
Well, great. We do have a drawing here at the end. If anybody wants to put one in while we're doing that. Erin sometimes places way too much power in my hands. And she said, hey, you can choose however you want to give out the prize, and you do a drawing, whatever. And so I have opted to see who has left the most comments over the course of this and who asked the most questions. And that person is going to get, oh, look, it's really obvious. We got a few people that ask questions. So El Teroit, I don't know, that's probably not the way to say that.
Yeah, looks like he was.
But you are the winner. So if you could send me your email address, I will forward you a big pile of awesomeness.
Yeah.
I mean,
let's see if I can show you what it is without showing you what it is.
Yeah, you can't show it because it has like a key on there, and then everybody's going to grab it.
Yeah, everyone's going to grab that key. So
I know how these people are.
Yeah, they're.
Oh, we're not. Oh, yeah. I guess we're on.
Well, I can open Teams here and see.
Hold on, this is the wrong screen. This is now everybody's seeing that. Oh no, we're not.
No.
Right.
We got two computers going. Just so we can show our friend what he won here.
Yeah, is that it? Oh no, I didn't send it to you.
I got it from her.
You got it from Aaron. There you go. It must be from Aaron. Oh, now I have it on my computer here. Anyway,
Anyways, there's a whole selection of IntelliJ products.
great.
and
Oh yeah,
it's real- it's pretty
good stuff.
cool. So you'll get some Python. I think there's some Python tools in there and like IDEs for working with Python and other things. So I
That's fun
think
stuff.
that was in there. So you should be able to.
Yeah,
help
just
you out
shoot
with
your
some
email address over.
Raspberry
We'll
Pi.
send it your way. Any last questions? Parting thoughts? And for Austin, thank you for doing such an awesome job putting this together. We've been talking about this for a long time. It actually came from another project that we've done. We worked on for somebody else a month or so ago. And just like, this is really cool. The level of automation that you can do these days is pretty astounding. So
Like clicking the button.
thank you for taking all the hours that it took to get a fairly complicated thing down to something that people can understand.
Yeah, I hope it was entertaining and insightful, and I hope you guys enjoy Signalr with your personal projects. And go ahead and like make an awesome garage door opener or some way to turn off your lights, or RGB's all the craze, so you can do all sorts of.
You can do all kinds of cool
you
stuff,
could
not
literally-
just servos.
Yeah, you could have your phone play music, and then it outputs whatever you want to to your Raspberry Pi, which then would show the light show. I don't know. You can do a lot of fun
Yeah,
things.
it's just super cool. The amount of stuff you can do with those GPIO pins.
Yeah.
And oh, hey, just real quick, we have this little thing right over here. What is this?
What is this? So normally you don't want to run a servo. Don't run a servo off of the actual Raspberry Pi. I only have one.
Power, right?
The power. So I only have
Okay.
one currently going. There's ways to hook it up differently, but I just have one, so it's safe. But if you had like two, or if I actually had a load, like if you put torque on this thing, put some weight, make it resistant, it has to use more power, more current, more voltage, and or not, yeah, not more voltage, but the voltage will drop in your
You
in
need
your
to give it more
Pi.
current to hold the
Yeah,
voltage. up.
yeah. So I should ask the electrician here. So this right here is just a power supply that will allow me to power these rails on the board. And so you can use this, you connect a little 9-volt battery, and you can choose between 3 volts and 5-volt output on there. So you can connect multiple servers in. So sometimes I have like 3 or 4 servo motors going.
So for this little one, you're just using the Pi power.
Yeah.
But if you wanted to, you could hook a
Yeah.
separate little.
So you would
DC
connect
power to it.
right here, here's the servo motor, right? I would connect the power
To one of the rails.
to one of the rails on here instead. And then I would just connect the ground. There's ways to do it. Don't take, but like the ground, you so make sure the signal grounded out with the Pi. So you just only connect the ground to the Pi.
Cool. Well, hey, thanks everybody for hanging out with us. Thanks again, Austin, for all the work it took to get this going.
Welcome.
We will see you in the fall. Have a good night.